Polarization is the process of creating two distinct and oppositely charged poles on an object. There are three major types of this. Direct contact, one example of this is two objects touching and stealing each other's electrons. Friction, which is the major example we covered of that in class, is the balloon in the wall problem, where the balloon becomes negatively charged, the hair steals the balloon's electrons, and so it creates a negatively charged balloon. And then induction, which is an example of this, is lightning, because the protons from the Earth stream up towards the negatively charged cloud.
So another form of polarization is induction, and lightning is a good example of that. And basically what happens is the clouds are charged through friction and they become negative, which induces a positive charge in the ground. And since opposite charges attract, the positive charges in the ground are going to creep up to the clouds because they're negatively charged. And then energy is going to rush from the ground up and is going to be released in the form of heat and light, which produces lightning, and then sound, which is the sound of thunder. There are two types of charges, positive and negative. And like charges repel each other, opposite charges attract. And in order for an object to have a positive charge, it has to have more protons than electrons, because protons are positively charged particles. And an object that has a negative charge has more electrons than protons. So this is the equation for Coulomb's law. F is the force, K is the constant, the two Q's are the charges, and then D represents the distance. And what that equation means is when you have two charges, the force and the distance between them are inversely proportional. So if you have a large distance between two forces, it's going to have a smaller force, and then if you have a small distance, it's going to have a larger force.
This recently rode balloon has a lot of negative electrons on it because of the friction, right? So when it gets close to that wall right there, it's gonna like attract those positive charges, because unlike charges attract each other, it's gonna repel all those negative charges right there, because like charges repel each other. And the force between the positive charges and negative charges is going to have a greater force because the distance is like small. You see that small d? And then the force between the negative charges and the other negative charges on the wall is going to be less because there's a big D. And this is all explained by Coulomb's law. To recap on what we just talked about, these are charges, right? Opposite charges attract each other. So these two, this positive charge and this negative charge, they're going to attract each other. And like charges repel each other. So this negative charge and this negative charge are going to repel each other, because that's how it is. Polarization. There's three types of polarization. There's direct contact, there's induction as we saw through lightning, and there's friction as we saw with the rubbed balloon. And this is Coulomb's law. F means force, K is a constant, the Q's are charges, and the D is the distance. When the charges are close together, it's going to have a big force because the distance is small. And when they are far away from each other, they're going to have a small force. That's it.